the order of operations basically corresponds to section R4 toward the beginning of our book. And I figured the first thing that was worth mentioning before we get to any examples, because that will be the bulk of this, is what do most people remember about the order of operations? And I think what most people remember is this. The please excuse my dear Aunt Sally, right? The PEMDAS. I think that's what most people remember. In a way, there is a subtlety to this, and I think that's worth pointing out, because you don't really go P, then E, then M, then D, and so forth. At the beginning you do, right? Because really what happens is that the first thing would be parentheses. Or, I mean, really it doesn't have to be parentheses, so I'm just going to write it this way as that it would be some kind of grouping symbols. So what I mean by grouping symbols would be things like brackets, right? Either kind, like the square brackets or the squiggly brackets, right? Things like that would also fall into that category. The next thing, the E stands for exponents, right? So I'm going to put that in here. But really it's exponents and roots. So I'll put that in parentheses here. So, and roots. All right. So the reason for that is because you could always rewrite a root as an exponent. If you're taking a square root, that would be the same thing as raising to the power of 1/2, right? So that way you're rewriting a root as an exponent. And effectively, that's just a difference of notation. So roots also belong in this step. The next two steps are really the ones where there's a little bit of subtlety, because it's not like you would then do multiplication and then division. You would do them both going left to right wherever they show up. So that's how I'm going to write this out, as multiplication and division. That S looks really weird, but that's somehow what that is. And another thing is, hopefully my handwriting isn't too sloppy. These things are not built for left-handed people. So like when I have to write a big word like multiplication, if I have to keep moving my hand, it kind of messes up where the cursor is. Big words are kind of tough. But you would do multiplication and division going left to right, and it's because you can always rewrite one as the other, right? Think about it this way. 8 divided by 4 is 2, but 8 times 1/4 is also 2, right? So dividing by 4, multiplying by 1/4, you end up in the same place. And you can always do that. And in fact, that's actually a common move, right? When you're dividing by a fraction, usually you rewrite that as multiplication by the reciprocal. So multiplication and division go together as one step here, really. And then the last thing is addition and subtraction. And they go together as well. So addition and subtraction. And for the same sort of logic, you could always rewrite one as the other, right? 9 minus 3 and 9 plus -3 are the same thing, right? You're going to get 6. But one of those is subtraction, one of them is addition. Okay, so scrolling down to where the examples are, the first thing, and I got to start with this because this is the kind of thing where at some point everybody makes this mistake. These are different, not by a whole lot, right? Basically, it's that they're the negations of each other. But with that first one, so the one without the parentheses, the exponent actually would take precedence, right? Here, really, you're just raising the 3 to the 4th power and then negating it, right? So the exponent effectively is the thing that you do first. Here, you're raising -3 to the power of 4, right? Because that negative is now inside the parentheses there. So the first one, so the -3 raised to the 4th power, that would be the negation of 3 times 3 times 3 times 3. And 3 to the 4th, if you don't know it off the top of your head, it's 81, which I guess you could get by saying this 3 times 3 is a 9, then this 3 times 3 is also a 9. And then 9 times 9 is 81, but what you get here is negative 81. And another thing with this not really being made for left-handed people, 8s are extremely hard, which I'm kind of learning today. And then the other one, the negative 3 to the 4th, there you would have 4 negative 3's multiplied together. So you got a negative 3, then another negative 3, then another, and then another, right? And you could say, well, negative 3 times negative 3 is 9. So this one I'll write out an intermediate step and say, well, then really the first 9 is the first 2, the second 9 is the last 2. And you would end up with 81. Okay, so be careful, I guess, with these sorts of things that look really similar, even though they end up being different. I mean, not all that different, right? They're additive inverses of each other, but they're not the same number. All right, then going down to the next one. Number 2. All right, let me get my cursor back. There we go. So number 2, we've got parentheses, and there's stuff going on inside the parentheses, so we'd have to do that first, right? So what we're going to do with number 2 is we'd say we got to deal with that 5 minus 7, which is negative 2. And then we're going to have to square that. And then we're going to subtract. And then this other set of parentheses, 3 minus 6 is negative 3. And we're going to square that. So if you square negative 2, so that's negative 2 times negative 2, right? So then that ends up being 4. And then on the other one, negative 3 squared, that's negative 3 times negative 3. That's 9. And so what you end up with here is, I meant to write it where I put the negative in last, and I didn't really give myself enough space. That's negative 5. I think I got the equal sign too far to the right, and that threw me off there. But yeah, that's basically what ends up happening there. Number 3, and this will be easier because I have a whole lot of extra room for my hand because this is on the right side of the page. I should just write them all on the right side of the page. Let's see. So the 6 is still going to stay out front. And we're not going to do anything with that right away because we've got some grouping symbols. We got a set of brackets. Within that, we do have a set of parentheses, but really that just ends up being for multiplication. However, that is the thing we're going to have to do first because we got multiplication here. We got subtraction here. So the multiplication is going to take precedence. So that 4 is still going to be out front. And then inside the brackets, it's going to be 2. And then minus 4 times negative 8. So 2 minus negative 32. And 2 minus negative 32 is the same thing as 2 plus 32, right? So I'm just going to rewrite that first. So 6 minus 4 times 2 plus 32 inside the brackets. Which, I mean, this step you could probably jump over if you were writing out your own work and just say, well, that's 34, right? Just from the 2 minus negative 32, I think that's fine. So it'd be 6 minus 4 times, and I guess I'll just still keep this in brackets, even though you could just write it like with a dot for multiplication. But then let's see, 4 times 34, because we got multiplication here and we got subtraction there. So multiplication would happen next. So that's going to be 136. So this will be 6 minus 136. And so then that's negative 130. And that's the answer. All right, so that one had a little bit extra going on. And they just kind of ramp up with a degree of difficulty. We got a couple of quotients here. This first quotient's actually kind of short. But let's see. So what we're going to have to do with these, and number 4 and number 5 are both going to be like this, where because there's a whole lot going on in the numerator and a whole lot going on in the denominator, it's almost like you could think of there being like a set of grouping symbols around everything in the numerator and around everything in the denominator. And really, if you wrote the division horizontally, so instead of like where you have the top and the bottom, if you wrote it left to right with the division symbol in between, you would actually need those grouping symbols. But then here, with it set up this way, you can almost kind of think of the numerator and denominator in isolation first, and kind of handle them individually. So In the numerator, the first thing you would have to do is multiply, because the two operations are multiplication right there and then subtraction right there. So if you multiply 6 times negative 3, you get negative 18, and it would be that minus 8. So we'll do that in the next step. And then on the bottom, really here, I guess the first thing that you can do is say, well, minus a negative, that's the same thing as adding a positive. So you can say this is negative 12 plus 7. And then you can just do those last two steps. So negative 18 minus 8 would be negative 26. And then negative 12 plus 7 is negative 5. Usually you wouldn't write the final answer with the negative in the top and the bottom. So to simplify this, we can just write it as 26 over 5. I think that's a good final answer. You could rewrite it as a mixed number if you want to, instead of leaving it as an improper fraction. But for some of the other stuff that we end up doing later, that actually ends up creating extra work. And I think the homework, like the Pearson homework, is set up to take it as an improper fraction rather than a mixed number. So there's another good reason to leave it as an improper fraction. All right, then going down here to number 5, I guess I'll just kind of scroll up a little. All right, so here, same kind of thing. So the first thing in the numerator, you've got multiplication of the 3/4 and the 12, and then you got addition right there. You gotta do the multiplication first. So 3/4 times 12, it's 9 if you're used to doing that multiplication. If you're not, it would be 36 over 4, and then you can probably see that that's gonna reduce to 9. But it would be that plus 9. And then on the bottom, we've got subtraction right there, and then multiplication. So the multiplication's got to go first. So 8, again, drawing the 8's really hard. And then I'll do the same thing here, and I'll just say that that's 12 over 2 if you multiply 4 times 3. And then we can simplify those two improper fractions now because they're both integers. 36 over 4 is 9, so you have 9 plus 9 on top. And on the bottom, you got 8 minus 6. That 8 actually looks all right, comparatively. So then that ends up being 18 divided by 2. And that's 9. And that's the answer. All right, so 5 was not really that different from 4, it just had fractions in it, which does tend to make things harder. I figured it was worth it to throw that in. Number 6. All right, looks like we got a lot going on here because we've got a couple of sets of grouping symbols, right? We've got the brackets, and then within the brackets, we got the parentheses. So I guess really what I would be thinking first is parentheses, right? Because that's the inner set of grouping symbols. So I would think we got to take care of that. So let's see what we're going to get here if we start worrying about the parentheses first. So that 6 is still there, minus 7, bracket, and the negation of 2 squared, minus, and then, okay, well, within the parentheses, what are we going to do? Well, we do have a couple of exponents, because there's one, the 3 squared. There's another one, right? We're going to treat roots like exponents because you could rewrite them as exponents. So 3 squared is 9, so we're going to have 2 times 9. And then minus 6 times the square root of 9, the square root of 9 is 3. All right, and then parenthesis and bracket. Okay, well then inside those parentheses, so 6 minus 7, this is all still going to be here, right? The negation of 2 squared minus, and then inside the parentheses, 2 times 9 is 18. 6 times 3 is 18. Oh, this worked out quite nicely, didn't it? Since inside the parentheses, that's a 0. All right. It's nice when that happens, because then that means we actually end up doing a little bit less work. Nothing wrong with that, right? So, let's see, negation of 2 squared minus 0. So really, inside the brackets, that's just the negation of 2 squared, right? Since subtracting 0 isn't going to affect the value of the expression at all. So 6 minus 7 times And I guess this is another step you could probably skip over if you wanted, but I'm going to leave it in for now. Just to say, okay, that 0 doesn't do anything. But then the negation of 2 squared, that's negative 4 inside the brackets, right? Because you would have to do the square of 2 and then negate it, right? As opposed to if you had the negative 2 in parentheses and you were squaring it, right? Then you're going to get 4. So let's see here. We're going to have 6 minus 7 times negative 4. And then we got 2 things left. We got subtraction, we got multiplication. The subtraction has got to go first. Or I'm saying that backwards. Subtraction goes last, multiplication goes first. 7 times negative 4 is negative 28, so 6 minus, I guess I'll put this in parentheses, the negative 28, which is, and I'm kind of out of space, so I'm going to have to start going left to right now. So this will end up being 6 plus 28, and that is 34. And that's the answer. All right, so that one, we had grouping symbols inside of other grouping symbols, but it's worth having that come up because that's a thing that occurs, right? So, all right, number 7. Number 7, this is one where it almost looks like you would think, I'm not even sure where to start with this. There's so much going on. And the things that kind of function as grouping symbols aren't conventional grouping symbols. Because you see, well, there's that big radical, and you go, well, that's an exponent. But we got all this stuff underneath. Or we got to do that first before we can take that square root. And then on the bottom, we got an absolute value, but there's a whole lot of stuff going on in there. So we got to do all that first before the absolute value. All right. Well, in a way, when there's all this stuff going on, like within the absolute value vertical lines or underneath the radical, it's almost like those function like grouping symbols because you got to do all that inner stuff first, right? And that's like how parentheses usually work. So, all right, let's see. I mean, we can still do it where we can look at the numerator and denominator individually, and I think that is the best course of action. So underneath the radical, we have a bunch of addition, and then we have some squares, right? We have some exponents. So exponents first, negative 5 squared would be negative 5 times negative 5, so it's 25, right? And then that plus 2, well, we're just not going to do anything with that, at least not yet. And then plus 3 squared, that's 9. And then, let's see, on the bottom, in the absolute value, we've got division, multiplication, and then subtraction. It's actually going to go left to right because you would do division and multiplication together, going left to right. So you'd actually divide first. So 24 divided by 2, that's 12. And then times 6, and then minus 5. Okay. And that absolute value symbol could look a little better. All right. So then, let's see, underneath the radical, we can just add all those together, and it's 36, right? 25 plus 2 is 27, plus 9 is 36. So square root of 36. And then underneath, it would be multiply first. So 12 times 6 is 72. So this is going to be the absolute value of 72 minus 5. Extend that division line a little. All right, so the numerator is just 6, right? Square root of 36. So that's not too bad. The denominator is going to be the absolute value of 72 minus 5, which is 67. But the absolute value of 67 is just 67. So 6 over 67. Looks like is what we're going to end up with there. Okay, so that one, it looks crazy at the beginning, and that's why I wanted to have something like that in there. Then these other two, these are just substituting in, but it's a different kind of phrasing. I figured it was worth going over. So we have this polynomial here, and it says evaluate it for x equals 3 and x equals negative 1. Well, basically then what you would do is you would sub in those values for x. So I guess we'll say for x equals 3, then you just sub in the 3's where the x's are, so you'd have 3 squared plus 2 times 3, and then plus 4. And then it's order of operations again. You got an exponent, you're going to do that first. So you're going to have 9 plus 2 times 3 plus 4. And then there's some multiplication that would happen next. So you get 9 plus 6 plus 4. But then it's just a bunch of addition, and that ends up being 19. And then you do the same thing for -1. So if we're going to do this for x equals -1, we're going to kind of do the same stuff. So we're going to sub in -1's for the x's. So you have -1 squared plus 2 times -1, and then plus 4. But -1 squared is 1. Then I guess we're still going to have the multiplication, so the 2 times -1, and then the plus 4. So multiplication next, 2 times -1 is -2. So, oops, I need to be an equal sign. Erase. There we go. All right. So then that would be 1 plus -2, and then plus 4. And I guess I'll do these one by one. It would 1 plus -2 would be -1. So -1 plus 4. And then that would give you 3. And that's the answer. I guess I can kind of circle these and not obscure anything. That's nice. And then number 9 is the same kind of thing. I guess a little less stuff for this one because it's just for one value of x. But it's the same concept where we're going to take the -2, sub it in for that x, sub it in for that x, and then simplify. So we're going to have 3 minus -2 divided by -2 squared plus 1. So 3 minus -2, same thing as 3 plus 2. So I guess I can rewrite it that way. And then on the bottom, -2 squared, that exponent's got to go before the addition. So -2 squared is 4, so 4 plus 1. So it looks like what we're going to get is 5 over 5, which is 1. And that worked out nicely. It didn't necessarily look like it would, but then it did. So that's always nice when it comes together like that. And that is the end of these problems, although there is another set that goes along with the live streaming lecture. So there are 2 different sets, and hopefully that'll be enough to where you can look at them and go, oh yeah, I remember this stuff, right? And if there are parts where you kind of think, okay, I haven't done this in a while, I hope within one of those or both sets of problems that anything like that, like that it'll show up someplace.